Hi students, we're looking at our last part of the chain rule here, and these are derivatives of inverse trig functions. These ones are going to be a little bit weird to set up, but if you set them up in this way, they don't require any memorizing, which is nice. All right. So if we've got to find the derivative of each of these functions, and I'm going to say with respect to x, we've got to take the derivative of x, which is going to be 1. The derivative of sine of y is going to be cosine of y times y prime. I'm going to end up with 1 over cosine of y is my derivative. Okay, cool. I'd love that with respect to x, but I don't really have that right now. Same thing for the other one. I'm going to end up with 1 is equal to negative sine of y times y prime. Getting y prime by itself, we get negative 1 over sine of y, and that's equal to y prime. We're going to be using this in a couple minutes to be able to do derivatives of inverse trig functions. And we're going to come at them from this approach instead of having to memorize rules for them, because the rules are weird. All right, and of course, why not start with something crazier? So I'm going to rewrite this as y is equal to inverse tangent of 4x squared plus 3. This doesn't look anything like what we were doing a couple minutes ago. So what I'm going to suggest is that instead of inverse tangent, let's rewrite this as tangent of y is equal to 4x squared plus 3. Then when we do the derivative of both sides, it's a mess of, there we go. Okay. We end up getting, okay, derivative of tangent is going to be secant squared of y prime. And on the other side, we've got 8x, and that's it. So if we're looking at this as y prime, oof, that would be a mess, is equal to 8x over secant squared of y. That's cool. I'd really like everything to be in terms of x. So we're going to go one step farther here, and now we're going to have a way to write something for secant squared of y. It's going to go back to this setup here. So we had tangent of y is equal to 4x squared plus 3. What I'd like us to think about this is in terms of a right triangle. If we've got tangent of y, we know that's an angle y, and we know tangent is the opposite divided by the adjacent. This could be written as a fraction over 1, so I could write this as 4x squared plus 3 over 1 for the opposite and the adjacent sides. To figure out the third side, we've got to use the Pythagorean theorem. And I'm not going to simplify anything because that tends to make things a bit of a mess. So I'm going to write this as 1 squared plus parentheses 4x. How did this get to be cubed? That's weird. 4x squared plus 3 squared. That's the Pythagorean theorem to find that hypotenuse. All right, last piece. I want secant of y. I know that secant of y is 1 over cosine of y. So it's the reciprocal of cosine of y. Secant squared of y would be the reciprocal of cosine of y squared. So if I could find what h over a is and then square it, I'd be okay. Here's my h. Here's my a. I'd like you to notice that the adjacent side is just 1. So in this case, we're just going to take this hypotenuse and square it. And we've already got a square root. So what's even nicer is that if we square that, we're left with just that thing on the bottom, that 1 squared plus 4x squared plus 3 squared. And we've got 8x on top. I'd like you to notice that 8x on top comes from the inside of the tangent. And we also see some weird pieces of that below, but nothing that is obvious from what we would have gotten for that as just kind of looking at that. All right, let's try a couple more of these. These ones are going to be a little bit easier for us to start with a harder one to make that a little bit easier going once we get here. All right, let's take some derivatives. We've got cosine of y is equal to 3x. I'm going to have negative sine of y prime is equal to 3. That gives me y prime is equal to 3 over negative sine of y. Now we need to find sine of y. So let's go from this point. Make my triangle. All right, y cosine is adjacent, so that's 3x over hypotenuse is 1. I'm going to use Pythagorean theorem. Hypotenuse squared is 1 squared minus a squared 3x squared. And then I need sine of y. Sine is opposite over hypotenuse. Hey, hypotenuse is 1. That's kind of nice. So what I'm really going to end up with here is y prime is equal to 3 over negative, and we've got 1 squared minus 3x squared. Okay. For our other friend, we've got sine of y is equal to x squared minus 1. So I did my inverse stuff. Let's take the derivative. We've got cosine of y times y prime is equal to 2x. Y prime is equal to 2x over cosine of y. Let's make a triangle. So we're going based on this part. Y opposite over hypotenuse is going to be x squared minus 1 over 1. We're trying to find the adjacent side. So that's going to be the hypotenuse squared, 1 minus x squared minus 1 squared. And if I want cosines adjacent over hypotenuse, hey, hypotenuse is 1, that's nice. We end up with y prime is equal to 2x over the square root, 1 squared minus the quantity x squared minus 1, also squared. And that's it. You're done. Looking at a couple of these examples that involve some chain rule things, I'm thinking I'm going to do C and let D be some fun practice for yourself. I might start this out kind of the same way with a couple of different warnings. The first thing, I'm going to take the derivative now so that we get y prime is equal to 5 tangent inverse 2x to the fourth. And I'm going to write this symbolically that we're taking the derivative of then this inside of this tangent inverse of 2x. Okay, for tangent inverse of 2x, I'm going to use z equals tangent inverse of 2x. And I'm also going to move that to the other side if it'll let me. No, it won't. I'm going to erase this and move this somewhere over here. There we go. I'm just going to use z because we already have a y in this problem. I don't want to kind of double variable up that. So we've got tangent of z is equal to 2x, taking the derivative. Secant squared of z times z prime is equal to 2. Z prime is going to be 2 over secant squared of z. All right, triangle up. We've got angle z, 2x over 1 for opposite over adjacent. And that means that my hypotenuse is going to be 1 squared plus 2x in parentheses squared. Secant squared is going to be h over a, so I'm going to take just this, since that's squaring it, and the derivative here, I'm going to keep this in red, and then the blue part is what we just figured out for the derivative. 2 over, instead of secant squared of z, 1 squared plus 2x squared. At that point, you are done. We got more of the same stuff here. I'll let you try these on your own. These look harder than they are. The other thing I want to make sure is that we know that arctan is the same as tangent inverse of the square root of x.